Hello, everybody. Welcome to S&P's Power Hour. We got about 30 minutes of information for you today on electric vehicles. My name is Al Dembrowskis. I'll be taking you through today's class, and we're going to cover a little bit of safety and some disabling procedures as we go through today. So let's get started here. So we're talking today about electric vehicles. Now, we have had hybrids for years. Okay, we have plug-in hybrids, and we now have electric vehicles out there. Before you work on any hybrid or electric vehicle or plug-in, always read your service repair information first, okay, for the specific vehicle being serviced. Realize that every vehicle has its own procedures, okay? So, and I don't want to generalize any particular vehicle here. So I just have to mention, we're dealing with high voltage, okay? High voltage can kill, okay? So this is why you must, absolutely must, make sure that you follow the proper service information. And when you are working on the vehicles, high voltage gloves should be worn, and we'll discuss that in a couple minutes here. Whenever you're working on anything high voltage, until you confirm that the high voltage is gone. Once you disable the system and the high voltage is no longer there, then you could take off your gloves if you so desire, okay? Following service information. Now, saying that, these vehicles do not have alternators, they do not have starters. So one of the things that you have to remember is that these high voltage batteries, and we have an example here of a Mach-E I'm going to bring up in a little bit, and we're talking over 400 volts DC in that battery pack, okay? So in order for the motor to work, the electric motor to actually do its job, there has to be a conversion from high voltage DC to high voltage AC. And that is going to be done in a component. Usually it could be separate or incorporated in inverter and converter assembly, or a separate inverter or separate converter. Okay, so we have to be able to take DC high voltage to AC high voltage. Also realize that because there's no alternator on here, we're also going to take that high voltage DC and reduce it to low voltage DC to charge the 12 volt systems on the vehicles. So all I want to really stress here is orange cables, okay? When you're dealing with orange cables, you are dealing with at least 30 volts AC or 60 volts DC or higher. And like I said, some of these hybrids are capable of over 500-600 volts. Okay, some of these electric vehicles are capable of over 500 or 600 volts on the system. So I do want to just mention a couple of safety tools here real quick. And let me give you an example here. So in this example, we have the fiberglass hook. This is hopefully never necessary, okay? This is to disconnect the technician safely from a high voltage. If you touch high voltage, there's a good chance your muscles will contract and you won't be able to let go. And this is so someone else can grab you and pull you away. I don't want to scare you. I just want you to understand that it's a real tool and it is out there. Also, I'm going to stress wearing your gloves. Okay, whenever service information says you should have these gloves on when you're working anywhere near high voltage, then you should have those gloves on. I can't stress that enough. Always look at the expiration date. Remember that there are tests on these gloves. And I do believe on one of our websites, we do have that test. Make sure that the other people in the shop know you're working on a high voltage, because they should be careful as well. Okay, you don't want anyone accidentally like trying to start the car while you're working on high voltage. So either put cones out or put the sign up to let everyone know that you are working on high voltage. And of course, don't forget your safety glasses here. Now, back over to my presentation. So understand when you're dealing with an electric only car, there is no internal combustion engine, which means there's no oil changes. There's no tune-ups. So that does change the management philosophy behind this, but they still are going to have air conditioning. They're still going to have tires and brakes. They're still going to have suspension problems, all the body electronics. There's more body electronics on these things than any other vehicles out there. So they are still going to break and they're still going to need repairs. Okay, they just are going to be slightly different, more on the electrical side than on the engine mechanical side. Okay, they're still going to have mechanical issues with the motors and batteries. So this is just an example. We have the DC battery. Now, again, that voltage could be very high voltage here. The high voltage battery is going to go into the inverter. That's going to change it from DC voltage to AC voltage, and that AC voltage is going to make the motor work. And then, of course, you have some kind of connection to the wheels, whether it's directly to the motor or you have some kind of transmission in it. But you do also have a 12-volt battery in these vehicles, and that 12-volt battery is there to work all the computers and all the lighting and all the accessories, because all that stuff is still 12-volt systems. Okay, so and one of the ways that electric vehicles can keep the high voltage battery charged, other than you plugging it in, is by regenerative braking. So whenever you're actually hitting the brakes, the electric motor is becoming a generator. And that electric generator is producing AC voltage. That's going back into the inverter converter assembly and changing it from high voltage AC to high voltage DC and recharging the battery. Now, I just want to say how efficient this is, that realize when you hit the brakes. Now, I'm going to go off on a quick. Most people have worked on an alternator on a car. Okay, and when an alternator is charging, you're producing a big electric field. Now, I don't recommend this, but let's just say you put a new alternator in a vehicle, but you did not fully charge the 12-volt battery. Okay, in fact, it's mostly dead. You start the engine up and you could hear that electrical whining from the alternator trying to charge that battery up. Okay, and that's a heavy electrical load. Well, that electrical load is what the electric motor on these vehicles is doing, is slowing the vehicle down. The quicker you want to slow down, the more electrical load it puts onto the motor, and it creates more electricity, and that gets to charge the battery. So that is, when you're in stop and go traffic, every time you're hitting the brakes, you're recharging the battery, which helps keep that high voltage battery lasting longer. Now, understand that not only do we have the high voltage battery in the vehicle, that is usually electric vehicles are only going to have lithium ion batteries, at least until something better comes out. There was nickel metal hydrates in hybrids, and they may have been used for a little bit in electric vehicles, but lithium ion packs more power for its weight. And so that is what they're all using. And of course, we have that 12-volt battery as well. And understand there's still going to be like relearns and everything else if you disconnect it. Now, the motor there's two different types of motors. One is a permanent magnet motor and one is an induction motor. And Tesla was big into the induction motors. What it is permanent magnets are pretty expensive. And to make it less expensive, the induction motor had no magnets in it. It creates a magnetic field when you have that spinning of coils of wires together. So it was a different approach. Now, I am just going to mention that Teslas do have some vehicles now with permanent magnets in it as well. So You have to look at the specific make and model of the vehicle you're working on, which way it has. So again, there's no alternators, there's no generators on here. All you have is the electric motor that's running the car, and also regenerative braking to charge the battery back up. Now, I do want to mention here that one of the things you have to be careful of is the electric cables. And again, they're going to be orange in color because they're high voltage. They are made to last a long, long time. Do not ever attempt to pierce them. That is the biggest problem. And if the vehicle is in an accident, make sure that you don't park that vehicle near other vehicles, because if a cable was pierced, we don't know what could happen. And there have been, a few vehicles that have caught fire. Okay? And you usually hear in the news. It's not a lot, but it's just to be prudent with your safety. And again, remember, we don't have an alternator, so we have a DC to DC converter where we convert the high voltage DC down to charging system voltage. Now, what happens when you want to charge this electric vehicle up? Well, the first thing you got to remember here is you're going to need a charger. Okay, so hopefully you have one in your house. Okay, you have AC levels 1 and 2 and DC charging. Now, the AC chargers are something that you could actually plug into your home. DC chargers, well, you'd have to have a special electrician, or you're going to a charging station. Of course, the vehicle is going to come with a charger, but level 1 charging, and this is more for older hybrids, it's the slowest form of charging. You plug it into a 110 outlet, and it may take 8, 10, 12 hours to fully charge a battery up. Okay, so that is the slowest form of charging. And a lot of times that's the charger they give you when you buy the vehicle, okay, because it's been around a while. Level 2 charging plugs into like a dryer outlet. It uses 220 or 240. And that is one of the more common ones that you're going to get for home charging, where you can have plug it in and you could charge your vehicle in roughly, 3 to 4 times faster than that level 1 charger. So in about, 3 or 4 hours, you can get a full charge into your battery. But if you really want to get some charge to the battery quicker, you need to go to DC charging. So DC charging is what you're going to find at the charge stations. So this bypasses the onboard chargers that are converting AC to DC to charge the batteries, and you're just going to pump DC in. Now, these are usually, connected to like a 480 volt supply or higher. So they can charge at a much quicker rate. And, in some examples here, you can get a good charge back into a car in less than an hour. So this is what you're going to find on the road. Now, the only thing I'm going to mention on the road, there are apps. If you have an electric vehicle that you can get, you don't have to have the electric vehicle, you get the app. But you can get these apps and you can actually find out where all the charge stations are. The only thing that the app doesn't tell you, and I think that there should be some kind of little update on there, is does the charge station work when you get there? Because it is an electronic piece of equipment, and if it doesn't work when you get there, or if a car is blocking it, of course, you can't charge your vehicle at the same time. But they're becoming more and more charging stations all over the country. Now, I also want to mention the high voltage interlock surface, because it's part of the safety. High voltage interlock is to make sure that before you can access a component that could have high voltage in it, you have to make sure that it's disabled. Okay, and we're going to show you one of those here in a couple minutes. High voltage interlock is a simple circuit. What it's doing is it's coming from a computer and it's going through components that have covers on them. So before you could take a cover off, okay, or while you're taking a cover off, you're going to open that high voltage interlock. And once the plate is removed, the computer won't allow battery power to be sent out of the high voltage battery to any components. So it is a safety feature if you don't disable the vehicle correctly to make sure that you don't get hit with high voltage. The only place that will have high voltage once the system's disabled is inside the battery. Okay, so that is something to remember here. All right, and there's some additional considerations I just want to mention. One is the tools you're using. You know, you've got to make sure you have the proper hand tools, proper voltmeters. There are different procedures to tow these vehicles. And even to get them into a neutral position. Okay, so understand that you're going to need this in order to, you know, work on it. You need that service information. Okay, be careful of any jewelry, watches, because you don't want yourself becoming part of the circuits. Verify the lift points if you're going to lift the vehicle up, because if you crush a battery or a cable, that could be a really, really bad day. Okay, if it was towed in from an accident, make sure it's away from other vehicles and structures. Most owner's manuals and the supplements, like the emergency response guides, can be accessed for free, okay? Especially the emergency response guides. That is something before you work on a vehicle, you always want to look at. Even if you're not a first responder, understand it shows you where the disconnects are. It shows you where the batteries are, where the components are. Okay, it goes into much further detail. It shows you where the, you know, all the high strength steel is, where the cut points are for emergency responders, but it gives you a good round outlook of the where the components are and how to safely work on it, okay, to shut it down. Okay, and remember, don't ever leave a vehicle until it's completely powered down. And those emergency response guides could be accessed at many different sites, and first responders have a lot of those sites as well. But one of the examples here is OEMonestop.com, and you can go into all the different manufacturers and access whatever emergency response guide you need. Now, let's go over and take a quick look. All right. So what we have here is we have a Ford Mach-E here. And I just want to point out a couple things. One, this is a full electric vehicle, okay? This vehicle has no gasoline engine. So it's purely electric. If you run out of battery power, you're sitting on the side of the road. And that is one of the reasons, personally, I don't like an electric vehicle, because at least a hybrid gives you the option to just put some gas in it and keep going. This, you're going to have to plan trips to go from either in the range of the vehicle when you can get there and back safely, or you're going to have to find that. That's why they give you apps to find the charge stations to go and charge them. And then you're usually at rest areas and stuff like that. Okay. One of the things I just want to point out here is now this is specific to this vehicle. This is part of the high voltage interlock circuit. And to disable this vehicle, you're going to disconnect the 12-volt power supply from the 12-volt battery. By disconnecting the 12-volt power supply, you're powering down all the electronics. And then you would disconnect this connector right here. And this connector is going to power down the high voltage system. At that point, you would want to make sure that you are taking a meter, a Cat 3 meter, okay, minimum, that is rated for at least 650 volts DC, and testing the circuits before you touch them that they are disabled. This is where you'd be wearing your high voltage gloves to check that connection, because you want to make sure the vehicle is totally powered down before you start to work on it. After you confirm that the power is not there, then if service information is prudent, you can remove your gloves so you can work on the car more easily. But until you're absolutely sure that the system is powered down, make sure those gloves are on. We don't have enough time to do everything today. So I'm just going to point out a couple of more things here. One, when it comes to orange cables, okay, and if you look inside here, you can see some orange connectors. Understand that there is no reason for you to ever touch an orange cable until it is disabled. Okay, and I've already mentioned it, but piercing them is an absolute do not ever attempt that. Do not ever attempt that. I just want to do one more little look here, and I want to talk a little bit about that charge port for a second. So I'm going to move this camera. The AC connection, that is your type 1 and type 2 AC connections. Okay, the bottom part is the DC connection. And you'll notice that DC is a much bigger connection here than the AC. That's why it could charge faster. Understand that there's a couple of pins in here. They are called pilot pins. One of these pins is to make sure when you take the connector and plug it in, that it is properly connected, that you can actually test that and you can actually see that in scan data that you properly connected this. The next pin is the computer on board talking to the charging station. And that charging station and the computer have to be on the same wavelength and saying, hey, I need this much current. It has to flow at this speed. Okay, and it's going to take this long to charge it. And depending on whether you're AC or DC, it doesn't matter. It still has to communicate that information back and forth to make this charge system work properly. So one of the strange things about that point is it is a square wave that goes into the negative voltage. And so that's a little different, and that's covered in other classes that we teach. So I want to stress the fact that if you are not currently in training for working on hybrids and electric vehicles, you definitely want to get some training in before you go off and work on your hybrid and electric vehicles, and follow all safety protocols. So at this moment, I want to open it up for any questions that we may have.
So Al, I did have a couple come in that I tried to answer the best I could, but I'm going to throw them at you just to see what you think. Now, this is not just electric related, but when you're driving a hybrid and you initiate moderate braking, you hear a whine that sounds like a siren in the distance. Is this a condition that indicates recharging of the battery? And my response was around the fact that, yes, you have the converter, inverter. You also have the electric motor. You will often hear those sounds when those are basically in motion. They're doing their job. It kind of sounds like a golf cart. Toyota's really notorious for that golf cart sound. Well,
yeah, and realize also that on a lot of hybrid and electric vehicles, especially on electric vehicles, they have to make a sound. Okay, because if their gasoline engine's not running, when you're like an example, if you have an electric vehicle and you're driving down the road and the road's nice and smooth, nobody knows you're coming. Okay, so if a deaf person is there, they can't hear you. So hybrids have to, and hybrids and electric vehicles have to make a noise to let you know there's something coming down the road. So that may be part of what you're hearing, but yes, and you're going to hear when you're doing moderate braking, you are going to possibly hear some electric regeneration happening. Okay, so there's a couple ways you're going to hear noises out of hybrid and electric vehicles.
And then I know we didn't have it in this presentation, but somebody was asking, do we have any pictures of the lifting points?
That is, if you look in the service information, you will find lifting points. Okay. There, I can speak for Ford definitely. I'm not sure about every other vehicle, but there are modifier guides out there available on the websites. Okay. There are emergency response guides, and of course the owner's manuals, okay, are usually available, and they should be in the glove box, but that's besides the point, that owner's manual, but they'll give you the lifting points. Okay, in general, once you look under the vehicle, you can generally tell, but because you could have electric cables running through boxes under the vehicle, you want to be super careful on your lift points.
Very good. And at the moment, we don't have anything else that's coming in. What I would do in the, oh, wait, I'm sorry. Here we go. Isn't the regeneration braking not when you're hitting the brakes, but slowing down?
Well, the regeneration, okay, can happen. It depends on the programming of the vehicle. But if you think about this, when you are just cruising down the highway and you let up off the gas pedal, you're going to coast. Okay, and that's what's supposed to happen. Okay, you're not going to be in a regen by just lifting up off the gas pedal. But as soon as you touch the brake pedal, that brake input goes to the computer and it knows to regen. Okay, now it's all going to depend specifically on the vehicle, but you know, if you're just going down a hill, unless you touch the brake pedal, it's going to probably get faster. All right, because again, you're not trying to brake. Now, most vehicles on that last, you know, like 5 miles an hour will use the hydraulic brakes. Okay, not necessarily, you know, a very big application of the hydraulic brakes, but they'll use the hydraulic brakes to do that last little bit of braking. One thing that does happen on these things is brakes have issues because of the lack of use, where that is a big problem, where you're going to have more braking issues. The pads last longer, but things rust and get stuck more often because of the lack of use. Now, understand that when you do a hard brake, you're not going into regeneration at all. It's the hydraulic system's going to take over, and it's going to go into an ABS stop, and it's going to do everything hydraulically. At that point, if you go into a panic stop, the hydraulic system takes over, the ABS system takes over, and it's all hydraulic at that point.
Very good. Well, it doesn't look like we have anything else coming in, Al. What I would like to say is for everybody who was on today, please join us again on Wednesday, September 13th at the same time. We're going to be doing another Power Hour and going over transmission coolers. With that, let's see here and make sure there's no questions coming in. We do have one more. Without vacuum assist on brake system, is there a hydraulic motor boosting pressure?
Oh, yeah, for the ABS system, absolutely. All right, because you're going to have that. You're going to have that. And understand that, you know, the brakes, and I should say the brake by wire is really where we're at here. Okay. The hydraulic system's always there to back them up. Okay. I don't know of any vehicle at all that's on the road that is gotten eliminated on a hydraulic brake. So there has to be an electric pump to keep pressure up in case of that ABS stop.
Very good. I think that answers that question. Well, we have gotten down to the last moment here. So with that, I want to thank everybody for being here. And again, check back in with us on September 13th when we go over transmission coolers. We hope everybody has a wonderful rest of your day. Al, thanks for your presentation today.
And thank you very much. Have a great time.